thank you so much for having us. Yeah, cats. But first, why are we here? And actually, I saw a trend this year. There's a lot of 2 people on the stage. So next year, it's going to be 3 people. So you just volunteer for 3 people. I was here last year talking about piracy. So that's the theme of this kind of section. And during that talk, I mentioned a big problem that most people seem to have, and that's having multiple CDNs and trying to use one token, and we heard tokens is really important. So I mentioned something called cats. So we're going to talk about cats. Will is going to talk about a standard, and then I'm going to try something dangerous afterwards. But I'll leave it with Will for a while.
Thank you very much, Anders, and it's a pleasure to be here. Thanks for the invite. So I should first start out by saying that if you're a cat lover and you were hoping for a talk on cats, the animal, you're going to be severely disappointed in the next 20 minutes. We're sorry for that. The cats we're talking about are access tokens, and that's why we're in the piracy section of the talk. If you saw in the previous presentation, a lot of pirates like to steal tokens and then reuse them. Why? Because if you're simply rebroadcasting the content, you, the pirate, have to build a CDN, and building a global CDN is difficult and expensive. But if you can steal the tokens, you can have the customer's CDN distribute your pirated content for you. So it's an especially lucrative part of piracy. So let's start then with an explanation of what is an access token. So if I want to give content to somebody, I first have to know who that person is, and once I've identified them, what are they authorized to consume and under what conditions? And this type of authentication is expensive, right? So I don't want to do it every single time I request a media object. And modern media players are requesting media, audio and video segments every 2 to 4 seconds. So we don't want to have to check the identity and the authorization on everyone. So instead, at the beginning, the user will share username, password, fingerprint. They will authenticate to their device. That will go to a back-end system, the authentication system here, and it will decide that they're a valid user and give them a token. And a token is a binary blob. It's encrypted information that's going to hold claims or knowledge about that user. And then what the user's player does is every single time they're requesting a media object, it gives it to the CDN. The CDN then shares the other half of those secrets and is willing to give up the audio and video segments in return. So it's a more efficient way of perpetuating an initially expensive operation in identity and authentication. So why do we need a common access token? An emphasis on the word common here. So there's 3 main reasons for this. The first one is that most distributors today are using more than one CDN. This is the Bitmoving study from last year. You can see that over 1/3 of distributors use more than one CDN. And I would argue the higher you get up the stack, that number is in the 80–90%. If you're a major broadcaster, you're using multiple CDNs. Every CDN has some token system that they've derived, and these were all built independently of one another. And that's part of the problem, is that your CMS system needs to create and derive tokens that are quite different from one another. And then you need to juggle them. As you're trying to switch CDNs, you've got to give the right token to the right person at the right time and match it with the CDN. Otherwise, you've DOSed your user. The second problem, because of the different CDNs, is that you're forced to go to the lowest common denominator of feature sets. So at Akamai, we have bi-level tokens, where you have a different token for the master playlist and the media playlist in HLS, for example. If another CDN doesn't have that, and you need to use a consistent experience across many CDNs, you're forced to use the simplest form of tokenization that works across all your CDNs. And then the third use case that just popped up this year is content steering. So content steering is a very popular way. It's the art and science of switching between CDNs on the fly at segment boundary. And it can lead to great results, but part of the challenge, especially for Dash, our content steering there is base URL driven, and there is no way to redirect query args or headers, for example, to give the new tokens with a base URL. HLS does have a schema for that. So there is a problem today. If you want to go out and use tokens across content steering, you have a little bit of a challenge. So a shout out to a group called WAVE, Web Application Video Ecosystem. Strange name, but they're a group that's been around for 10 years right now, 60 different companies. It's a global group that's trying to solve interop problems in OTT. They identified this problem back in 2021, almost 3 years ago right now, and kicked off a work group and said, let's create a common access token that everybody can use, all the media companies can use for distribution. We decided to call it Common Access Token with the acronym of CAT. CAT's easy to remember, but also it extends upon the naming scheme that Wave's used for other popular standards. CMCD, Common Media Client Data, and CMSD, Common Media Server Data. So that's where the name comes from, Common Access Token. And the spec, we've been working on it for almost 3 years. We meet every 2 weeks. It's a long process, but it should be released next month. It was meant to be released in April, but it's probably looking like June. But we're right at the end of it, so you're going to start hearing a lot more now as CDNs take it into production, and hopefully clients, players, and ecosystems as well. So, what is a cat besides the animal? So very simply, it's a bearer token. It's a general purpose token. CAT was developed specifically for audio and video, but there's nothing constraining its usage to that. It protects delivery of any binary object schema. It's simple and it's extensible. And it communicates what are called claims. A claim might be that you're on a certain device type, or that you're in Stockholm, or it's past 8 p.m. at night. And we'll go into some of the more sophisticated claims that we can support here. Its primary use case is to enforce these policies and do it efficiently, flexibly, and more importantly, in an interoperable way between all CDNs. I want to explain these two words. You might have a question about pronouncing them. The pronunciation is not what you would expect. If you read the specification, JWT, it's meant to be pronounced jot, which sounds quite Nordic, so maybe more people pronounce jot here. And CWT is pronounced cot, so jot and cot. No one I know actually uses these terms. We call them JWT and CWT, and those are the terms I'm going to use today. I just can't force myself to the other explanation. So why are they relevant? So JWT is a JSON Web Token. We use JSON to describe a set of claims, and then we use JSON Web Signature and JSON Web Encryption to sign and encrypt those claims. CWT is a CBOR web token. It's very similar. Claims are described using CBOR, compact binary object representation. It's basically we're trying to make these things smaller. And then we sign them with CBOR object signing and encryption, which has the nice acronym of COSY. So just a practical example of what this looks like in real life. Here's some JSON describing some claims. Here's the equivalent markup. Remember, CBOR is binary, so we're not actually seeing it, but basically replacing strings with numbers. That's how we get our compaction. If I turn the left-hand side, the JSON into base 64, which is how these tokens are often transmitted, or almost universally transmitted on the web, 208 bytes. If I do the same with my CBOR, 35 bytes for the same set of claims. So that's why Common Access Token uses CBOR. We want to be smaller across the wire, especially for audio streams. We don't want a large penalty carrying a very big token. So how do we move cats across the wire? There's a number of ways to do it, and I think none of them will actually surprise you in the delivery realm. So the first is a path style parameter, where we just have a URL and we embed our token as part of the path. And notice I've put a short token in so it fits on the screen. Down the bottom is an actual real length token. So it's a little bit larger, but it's not crazy big either. Then we have form style parameters. This is actually a post, and I just put my information in my form. I put the same token in there. We can use cookies, Common Access Token cookie right here. We can use the auth field with the bearer prefix. This is a standard bearer token, and it can be used as such for protection. And then the very common usage with just headers, essentially, in HTTP. And we're trying to standardize upon common dash access dash token as a standard name. You can call it anything you like as long as your player understands it. But we'd like to call it that so that all players can understand it without having to be specially trained. So what claims can we support? I mentioned that the claims are the real key to security. So most tokens in that race to the bottom, they will at least support expiration. They will say, here's a token, and you can request anything you like from the CDN for the next 20 seconds or for the next 2 hours, depending on what the expiration time is. But with Common Access Token, we're far more sophisticated than that. We have all these different claims that you can now protect against on the fly. And they enable quite efficient and sophisticated protection. And not only do you have the individual claims, but you can have Boolean combinations of those, and, or, and nor between them. And we have conditional logic that can be applied within the encrypted claim as well. So what you can do is you can pick from a set here. You can take any one of these claims, and you could say or them. So I must be in Stockholm, or I must be in Norway. And then I can AND that with some other condition. And I can also expand it and say, if I'm on a Samsung TV, and if I'm in Norway, and if it's past 8 p.m. at night. So you can develop very complex scenarios that you want to protect. And the tighter you can, fine-grained you can control your protection, the further down the road we can get in the battle with the pirates. So some super high-level use cases of the sort of things we can do with these tokens. So first of all, the claims have different names: CatU, Exp, CatGeo. They're just abbreviations, but these are what they actually look like in the markup. This is baseline access. I want to protect my URL, expiration time, and some sort of geo-based detection. CDNs do this all the time. Then I have a CTI. It's an identifier, and we're going to see this later in the demo. CTI plus replay, this stops tokens being reused. Now, every token can have an ID, so the obvious way to stop them being used is every time an edge server validates the token, it registers it in some central database. But if you've got 10 million people for a large event all registering, you have a real scale problem with that database. So there's some other interesting solutions here. CatPoor, which is not a poor cat, it's probabilistic rejection. I will explain. This is a very interesting way to address that scale problem of stopping replay usage. And then one of the later forms of protection, DPoP, distributed proof of possession. It requires a secret on the device, but once you have that, you can do some interesting things. So these are at a high level. So just to give you an idea of what cat might actually look like. So here's a JSON diagnostic. Remember, we're not JSON, but we want to be able... JSON's nice for us engineers to read. So you can see that I have string names for my various claims. And then what we do with CBOR is we give each of those strings, we give it a number in a document. So it's not too complex here. I make my object smaller by just trading strings for numbers. And I take this CBOR, and then I'm able to base 64 it. And that's the token I would actually send out across the wire. And the token has a signature. So if the pirate modifies the token, the CDN can tell that it's been messed with, and they're going to deny it automatically. Now, as part of geographic protection, the classic geographic is you can block by country or state, and there's IP to country-state matchups. And there's also lat-long blocking, and you can block in a radius of a lat-long point. But that's not a very sophisticated way, right? I might want to block, say, the Paris region for a PSG game, but I don't want to block outside. And Paris is not a circle. Right. Actually, Paris, that's a bad example. Paris is sort of a circle. Pick your city that's long and wide and not a circle. And so there is a standard called geohash, and it's actually quite popular. It's a string like that. U3 is a geohash, and depending how long your string is, it can go up to 9 characters. It describes an ever... the more characters you have, the smaller the rectangle it describes. You can go right down to a 3-meter square on planet Earth, assuming I don't fall off my square. So this is a great way. We thought this would be nice to use inside cat. But when we looked at it, Geohash was defined by a wiki entry, which is also convenient, but it's not something we can reference in a standards document. So as part of the development of geohash, actually I was just showing you an example here. This is the geohash string for hotel at 6 where we are now. And that's not even the smallest one, right? We can come down to a 3-meter square. So as part of the development, we actually released a referenceable version of geohash. It's called CTA 5009, and you can download it. It's free to use, and you can go test it out on this page here. There's a lot of online examples of geohashing. This one's the schema here is compatible with it, but at least now we can use it. And these rectangles, you can add them up, right? So you can develop a very interesting, irregularly shaped blocking and protection area. Catnip. I did say in the summary I talk about it in English. Catnip is this weird plant that cats like to eat. I'm not a cat lover, so I don't know if cats actually eat it, but it's mythology. But in the token world, yes, it's our IP claim. So it allows you to block not only AS numbers, you can block, say, on a mobile CDN, but you can also block IP for addresses or prefixes, CIDR blocks. And here's an example of a token that's, in fact, it's authorizing a client to connect on a subhash of a network address. So catnip is a thing, and it's a sophisticated way of blocking subnet ranges and ASs. Can you block by altitude? Well, of course you can block by altitude. So we have a claim for that. Now you might argue, why are we biased against people who live in mountains? What's the possible use case for blocking by altitude? The very interesting use case is VPN detection. So if I'm here in Sweden, in Stockholm by the water, and I have a VPN into Denver, which is at 1 mile high in the US, my phone will report the altitude, or report the pressure that my application can read. And I can enforce that I expect that phone to be at a certain altitude in order to allow playback of the content. And if you're not at that altitude, we're going to block you. And it's far harder to fake out the pressure sensor on your phone than it is to fake out your position. So it's not foolproof. There's ways to do it, but it's just another step in the battle against pirates. So altitude is in there. Renewal is also very important. One of the ways the pirates love tokens is if they're long-lasting, 2 to 3 hours. So we need a way to replace them quickly. You could replace the tokens every 10 seconds, a minute, 5 minutes, some interval you like. And more importantly, it can be done by the CDN serving the token. So we need an instruction to allow the token to be renewed, and we also need a claim that tells you when you should renew it and what's the warning window ahead of when it's going to expire so that the renewal process can kick in. And when we do renew it, we have 3 mechanisms for doing that. Cookies, so we set a named cookie defined by the token. We can do it with header. We have a defined name for that. And we can do it by redirecting the player to a new URL that happens to include the token as a query arg. So 3 different mechanisms for renewal. Now, I mentioned earlier that there's a way to attack piracy with probabilistic rejection. So why would we ever want to reject an otherwise valid token? So what this is saying is the player is going to present a valid token, and I'm going to roll a dice, and some percentage of the time I'm going to reject that token and force the player to renew. And the reason I want to do that is pirate pain. And it's an asymmetric pain. So let me explain here. And this is, I got a chart here courtesy of Cinemedia, who were presenting this data. So let's imagine we have a token that we're going to randomly reject 0.005% of the time. Then if I'm a valid user, and assuming we're requesting a segment every 4 seconds, a valid user has less than a 2% chance after 5 minutes of having to renew because they're the only person using that token. But a pirate who's sharing it with 10,000 users, within 2 segments is going to be forced to renew. And every time you force the pirate to renew, they have to circumvent all the security patrols. So it's a very clever way of asymmetrically penalizing the pirates, but more importantly, it does it in a stateless way. We don't have to report all the tokens to a central database. We simply roll the dice at every edge server, and we can do that very efficiently. So a final example before we go to an actual demo. Let's say we want a token to present an asset. I want to protect an asset. It must be a path of this string here, and it must be before this date. So here's what the token would look like. I have an expiration claim. That's this date in UTC seconds. This is the URL claim. Within it, I have a path and a prefix, and I tell my prefix. This is a valid and pretty minimalistic token. And this is what that token looks like embedded in a URL. I just put semicolon cat equals. This is totally up to you. You can bake it in. It's how you like. It's protecting a manifest. This is using ES256 asymmetric key. And just as an example here, that if we allowed 3 different keys in cat, and if we happen to use PS256, you can see the same data is much larger. So if you do use cat, be very careful about the encryption mechanism you do use. It can change the size of your token. Now, I've shown you theory so far, but we're an engineering company, and Anders is an engineer and loves to build demos.
It's actually an error there.
Oh, yeah?
In the middle of the, yeah.
Nice.
Okay, so we're going to try something that has never been tried on this show before. So I'm going to do a live demo. But first of all, just go through what are we going to show. First of all, we have a player. The first player we're going to use is Dash.js. It's version 5, because I'm using some intercepts and other things that just came out in version 5 that can help us alter the traffic going in and out of the player. Then we have a token generator. In my case, it sits on the CDN, but it really doesn't matter. Normally, you would actually do it the other way around. So our demo will show how you created a token from the customer side or the client side, but that's not really how you do it. You do it on your CMS. And then, well, already talked about CDN. We validate the token. We go to the origin. But also, we do randomness. So we switch between CDNs. And finally, we're going to try to block these tokens as well. One question that I came to think of when we talked about tokens was, okay, so how much time does this really consume on the edge server? Are we going to get delays by doing these sophisticated tokens with decryption and all that stuff? And this is the result. So I ran a number of thousand requests, and roughly 22 milliseconds without verifying a token, and with verifying a token, 35 milliseconds. So not too much, and I think there is room for improvement here as well. This is just my naughty code, so it can certainly be improved. I think that's, yes, we're going to do some demo stuff. So can I have a table? This is now super dangerous, and that's never... There's no risk of any issues here. We'll see. Yeah. First of all, you need to remember your password for your computer. That might be your first obstacle to. Okay, let's do. Okay, so we have a demo interface. Essentially, it's a player debugger, whatever and I created it like over a week. So up here we have some base information. It's the URL for your media. You already know that. You can turn on CDNs, different CDNs. Some basic information. So when does the token expire? And when it has expired, how soon do I want to renew it? So this might be the time to kind of introduce the right thing here. Will already said the minimum token we can do is expiration, but let's turn on renewal as well from the start. I think that makes sense. So you see, we just extend the JSON. And the JSON here is a little bit more prescriptive. I'm actually writing out what these things are, but they are numbers in reality, so they're way smaller. Then I have a number of other things I can add, and you can extend this list how far you want. I included a special one, which is called interest, and we're going to get into that. And then you have positioning, and I'm using radius and position as my baseline. And up to the right, we have a player as well. So, okay, let's try this. Let's create a token out of this. And what you will see here in the right-hand corner is a token popping up. So I have a token, and I should be able to play this. And now It's time for excitement. Yes, it works. Okay, first obstacle. So what can we do now? We can see a lot of things happening here. We can see the CDN. We can see that tokens are being fetched, and yellow, yes, it's also renewed. I can be more aggressive. So this is now renewing every minute, but let's set it to expire every 20 seconds. So now the token will expire every 20 seconds. And you will see there will be a lot of more renewals happening here. Yeah, you see almost every segment or every object we're actually renewing. So you see that in the yellow there. But okay, the main obstacle, 35% was it, that had issues with multi-CDN. So we turn on multiple CDNs, and you will see that the URLs here will go to 2 CDNs, and you will also see that the CDN here changes. And the renewals happens through both CDNs. They have no knowledge of each other. They're just doing this as the standard spec says. Okay, so let's do something. Let's use one of these claims and do something with it. So the path, for example. I can say that it should contain. Funny enough, my URLs actually contain cat, so let's do cat. And I'm pushing create token. So now I'm creating a token, and the next time the player will ask for something, it will use that token. Cleverness. So, and we can see in the claim, it's here. So you see that the cat is there. Okay, but does this really block anything? Does it do anything? I said I would have put cute here, but Will came up with dog, so let's do dog, and we're going to put dog here. So what will happen? And we haven't fetched any objects, but yes, as soon as we fetch an object, you're blocked. So if someone fiddles with anything of this, they will get blocked. Final thing to show here, I think we can have some video playing, maybe. Final thing to show here is around geos, and I'm going to use radius. So let's go back to the claim so you get an idea what's happening here. So if I add a position here, you'll see it's null, no, nothing. I haven't put a position, but I say I want to put a position. So I have 50, that's like, yeah, 5,000 kilometers.
50 kilometers.
50, yes, sorry, 50 kilometers. So yeah, I have an area here which I will cover and which I will allow. So let's go over to the video. I'll do this. So I get immediately blocked, and the reason for that is that I'm obviously not in Örebro, which I think I hit Örebro there. So I'll do it this way instead. I create a new token, I load the video, and off we go again. So that was the first part, and now I'm going to involve all of you, and this is where it's getting really dangerous. Probably I should stop playing here as well. So up with your phones. And choose an interest. I don't know. There's a lot of... we had some interesting findings yesterday, but I will tell you about those afterwards. And we will also see if this works out. I think everyone is there and probably has some playing video. Can I borrow you, Magnus? You're going to be my volunteer here. So now you're going to block people. It could be that something is not playing, and it's like this is a night hack for like the last 24 hours. But what Magnus will do now is he will push one of these interests and see if you're blocked. And if you don't remember what you pushed, you also have a little small icon that says what you actually pushed, so you will not be able to fool yourselves here. Okay, go ahead. Fish. Okay, that's going to be interesting. So we sent that data to the CDN, and I think actually most of the people will already have been blocked before we even see that on the screen. So just quick poll. Did this work for you who chose fish? Are you stopped? It seems like it. Right, and I think that's also kind of the trigger, because I see our timing is also red. So I think that's also the timing for us to end our talk here. So with this, thank you so much. If you have questions or if you want code examples and stuff like that, we can help you in the pause.
Thank you.